Today we're going to talk about some more one variable statistics, and we are going to get started today with distribution. So distribution is going to be the shape of our graph. It also talks about how the points in your data set are distributed, how spread out they are, and in what way they are spread. When we make like a dot plot, for example, or a histogram, you can either have where there's a lot of data over here on the left and a low amount on the right, where the majority of your data falls in the middle, or where the majority of your data is on the right side of the graph. These are three different types of distribution. The one in the middle is going to be symmetric. So symmetric data looks exactly like what you would expect, where the high is in the middle and it looks like it's about the same on both sides from there. Now, when the high is either on the left or on the right, we say that this data is skewed. So your data can either be symmetric or skewed. Now, the way to tell the difference between these two, where the high point's on the left or the high point's on the right, is to talk about skew direction. Okay, so we are going to say that these two different distributions are either skewed left or skewed right. But skew direction is where the tail of your data is. So it's the opposite of where the high point is. So for this one over here, we say this data is skewed right because the low point is on the right. And so for the other one, this is going to be skewed left because the low side is on the left, or where the tail. If you imagine that this is a dinosaur, your tail is going to be way over here on the left-hand side, so that's the skew direction. Now, when we have symmetric data and when we have skewed data, we want to talk about these two different types of data sets differently. And so for that, for symmetric data, we are always going to use the mean and this something else called the standard deviation. Another word for mean is average. So when we're talking about, like when we want to talk about the middle of our data, this point right here, we want to use the mean or the average to talk about that. And then standard deviation is a number that just tells me how spread out my data set is. So how like far apart those are, those values. Your calculator will figure these out for you. So in the calculator, you're going to want to press stat enter so that we can access our table, and we're going to put our data in L1 just like we have done in the past, and then we want to press stat calc 1. Let me grab my calculator so I can show you what that looks like. Okay, so in my calculator, I'm going to press stat enter, and you can see that I already have a set of values here in L1. So I'm just going to go ahead and use those just to make that a little bit easier for us. And then I'm going to press stat calc in 1. So stat, we go over to calc, and then we have option 1 for one variable stats. If you recall earlier, we did stat calc 4 for our linear regression, but now we want stat calc 1. So I'm going to press enter, and then I just need to enter all the way down and select calculate, and this information pops up. N equals 16 tells me that I have 16 data points in my list. And now this is the information that we want to know. So in here, this very first value, this X with a bar over it, that represents our mean. So X bar is the value for mean. And this last one here this little O with a little thing at the top. That's our standard deviation. I commonly refer to it as ponytail because it looks like a girl with a ponytail sticking out of her head. And that is what represents our standard deviation. Mean is a measure of center. Standard deviation is a measure of spread. So those are the best options to use when we're dealing with symmetric data. Now, if we are dealing with skewed data, we don't want to use the mean or the standard deviation. Skewed data will use the median, which if you recall is the middle value. And then for our measure of spread, we're going to use something called the inner quartile range, or IQR for short. To find IQR, we're going to use values from our 5-number summary. Remember, from a box plot, we're just going to take Q3 and subtract Q1. That actually tells me how wide my box is in my box and whisker plot. So skewed data is going to use median and IQR. I'm going to make you just a little chart here to help you out with this. There are 2 different measures of center. There are 2 different measures of spread. And then our data could be symmetric or skewed. So here's my little box. Let's go ahead and fill this out. For symmetric data, our measure of center is the mean, which in a calculator is X bar. For skewed data, our measure of center is the median, which is the middle range, or the middle number, excuse me. For spread, we use standard deviation. I'm going to abbreviate that as STDDEV, standard deviation, which in your calculator is this little ponytail. And then our measure of spread for skewed data is IQR, which is Q3 minus Q1. Let's add a little bit to this here. This is how you do this in the calculator. Mean and standard deviation are both done the exact same way in your calculator. That's stat calc 1. And then if you recall from yesterday, a median and IQR can be found by pressing zoom 9 trace. Let's do an example. Okay, for our example, we are going to create a dot plot, determine distribution, find the best measure of center and spread for this data set here. So to create our dot plot, the first thing that I want to do is draw our number line. And that's one thing we don't have made already. I know my number line has to go from 63 to 75. So 75 is going to be the largest number. So I'm going to make that 70. That'll be 65, and then I'll have, okay, it's a little, so we can make this 60, which we don't have to have every single value. You can see that my number line is a little bit wonky, but that's okay. So long as you can put every single one of these points on here, you should be able to see the spread, the distribution well enough on here. So to create our dot plot, I've got 1 at 63, 1 at 64, 2 at 66, 2 at 68, 1 at 69, 2 at 70, 2 at 71, 3 at 72, 1 at 74, and 1 at 75. So here is my distribution. If I just take my pencil really quick and draw over the top of this, I want to make it look as similar to one of these options as possible. So I'm going to draw over the top here and see what happens. So I've got this, and then it goes up and back down. So here's my distribution. I can see that my highest point is right here, and that's at 72. And then there are more values to the left than there are to the right of that high point. So that means my tail is going to be over here, which tells me that for this data set, it is skewed to the left because we have a tail to the left. Or the other way to think about it is from our highest point, there are more data points to the left. So that makes it skewed left. When we are dealing with skewed data, that means I want my median and my inner quartile range. Now, there are two different ways that we can move on from here. I'm going to show you how to find the median from a list of data right now, but then I'm also going to show you how to find these two values in the calculator. So for median, I want to know which number falls in the exact middle of our list. Not the middle between 63 and 75, but the actual middle of our data. So I'm going to start with my fingers on either sides of my list of data. I'm going to cover up 63 and 75 at the same time. Then I'm going to move in 64 and 74. And then I'm going to keep going, and I'm going to keep pairing up these numbers from outside in until I get to these two 70s in the middle. If I cross them both out, the thing between 70 and 70 is 70. So my median should be 70. That's my middle value. Okay. You could find the inner quartile range. You could find Q3 and Q1 from this set of data pretty easily, but I'm going to show you in the calculator to make sure that you have that. So in the calculator, we are going to press Stat and enter, and we're going to put our list of data into the calculator. So 63. Okay. When you're done, we are then going to press Zoom 9 and trace. So you can see my median is at 70, so I did that correctly. Now for inner quartile range, we need to do Q3 minus Q1. So Q3 is 72 minus Q1, which is 67. Q2 minus Q1 is 5. So my inner quartile range, or my best measure of spread, is 5. That's it right there. Now, before we finish up, I want to show you how you would tell the spread on a box and whisker plot, because that one's a little bit more difficult than a dot plot or a histogram. You can't draw these curves over the top of a box and whisker plot, but the idea is still the same, the direction where the tail is. On this box and whisker plot, I want you to find the median, okay? It's here. And then I want you to look at the distance from the median to the minimum and the median to the maximum. You can tell that this half, the left half of our box and whisker plot, is larger than the right half. So that's how you can tell skew and direction, is that from the median to the left is the longer distance, therefore it is skewed to the left. That's where our tail would be. Okay, so you are just looking from the median to the ends of your whiskers, and whichever one is longer, that's your skew direction. If it's in the middle or really, really, really close to the middle, that's how it would be symmetric.